Modeling and Simulation, or M&S, is playing an ever-increasing role in conducting Navy's operational assessments. The very nature of M&S allows us to run literally thousands of iterations of many different scenarios under varying environmental conditions to paint a clear picture of our military's ability to counter emerging threats. M&S supports assessments at all levels of aggregation, from campaign level to one-on-one engagements. Wargaming exercises, like those conducted at the Naval War College, bring experts together to help the CNO define and analyze future naval missions and force structures, and to help Navy make important investment decisions. Models are used to adjudicate force-on-force engagements and to provide in-depth analyses of tactical and strategic alternatives. The General Campaign Analysis Model, or GCAM, is a PC-based tool suite designed for global crises analysis modeling. GCAM is used to examine events ranging from major theater wars to smaller contingencies and operations other than war. M&S is used to support assessments of alternatives, or AOAs, a required step in the acquisition of military systems. M&S helps us develop measures of effectiveness, assess platform vulnerability, and estimate total ownership costs. In developing platforms such as the 21st Century Surface Combatant, or SC-21, we are using M&S to eliminate unnecessary requirements, mitigate the risk of unmet requirements, and avoid expensive design features for which there is no requirement. Using SIM2 and the Mine Search System model, we can validate unmanned undersea vehicle requirements for speed and acoustic performance, and test the UUV against known threats. Modeling and simulation is a valuable tool for analyzing emerging technologies. M&S helps us explore the operational appropriateness of new technology and the application of older technology to new missions. Using simulation interoperability standards, we can connect geographically distributed simulation resources and use them to perform system assessments. If we combine these with live forces at training sites or afloat, we can significantly enhance the quality of the assessment while allowing the warfighter to gain valuable operational experience. Acquiring today's sophisticated weapon systems would be nearly impossible if it were not for advanced modeling and simulation technologies. With engineering and design models, we can iterate multiple designs quickly and efficiently in a synthetic environment to optimize the acquisition process, reducing both the time and cost to field our systems. Physics-based hydrodynamics models can help us formulate submarine hull shape concepts. Models like these allow us to optimize submarine hulls for efficiency and stealth while reducing the required number of expensive hardware prototypes. Models give us insight into certain complex behaviors. For example, we can slow down time to study rapidly changing aerodynamic phenomena more closely. In the virtual world, time is just another parameter. Likewise, when analyzing the trajectories of airborne ordnance, we can expand each instant of time into several seconds, allowing us to see the air-body interactions in much greater detail. In this example, a fluid flow model is being used to analyze torpedo launch dynamics with a level of accuracy that is difficult to achieve in a real launch. We use high-fidelity simulations to help us determine overall system effectiveness. By integrating sophisticated transmitter sensor models with physics-based propagation models, we can accurately simulate and analyze Spy-1 radar detection capabilities. We use models to analyze the sensitivity of complex behaviors to changes in environmental conditions. In this case, a model is being used to predict the behavior of minefield clearance netting to changes in wind conditions. From analyses such as these, we gain valuable insight into a system's operational performance. Modeling and simulation can be used at all levels of design detail, from individual components to larger systems such as a submarine periscope, to highly integrated warfighting technologies like the LPD-17. In each of these cases, we can better understand how the final product will perform, how it will interact with the other components in the system, how it will look, and how the operators will employ the system to fight the war. We can no longer afford to treat each stage of the acquisition process as a separate and independent step. we must consider both the manufacturability and cost of the systems we design. Manufacturing models allow us to go through the rigors of manufacturing a complex system without opening the doors of a single factory. In addition to building these products entirely on the computer, M&S allows us to design the manufacturing tools, processes, and facilities for eventual real-world fabrication.